This is Will. Today I'm gonna do the review for the engine, gas turbine engine maintenance review in our hangar. And this is our gas turbine section. And in this section, gas turbine maintenance, we learned the operation. And for turbojet, turbofan, they just use the single controller for the fuel flow. And for the turboprop, they have 3 levers: power lever for engine speed, prop lever for propeller, and condition lever for the fuel flow. And next we learn the engine instrument. Common instrument with the reciprocating with like oil pressure, oil temperature, engine speed, EGT, and fuel flow. And different instrument from the reciprocating is the EPR, engine pressure ratio, and the turbine discharge pressure and the torque for the turboprop and turboshaft. And there are multiple temperature thermocouple sensing instrument. Turbine inlet temperature and ITT, TGT, and TOT, they are all standing for the EGT. And the most critical temperature is the TIT, turbine inlet temperature. Next, we learn the compressor speed. Compressor speed displayed on tachometer, calibrated in percent of RPM. And for the twin spool, low pressure compressor speed used in one tachometer, high pressure compressor speed used T&2 tachometer, and centrifugal compressor RPM standing for the thrust. The axial flow compressor RPM for engine starting and help identify overspeed consideration, and turboprop NG tachometer standing for the engine speed, NP tachometer for propeller or freight turbine speed. And there are 2 types of the tachometer. First one sends the fan speed or the low pressure compressor speed, measure the frequency of magnetic field interruption by fan blades measured by electronic circuit and the transmitted gauge. And another kind of tachometer is the gear-driven shaft induct voltage and frequency measured by electronic circuit, and also it can be called the tachometer generator. Works like a generator. And for next section, we learn the engine pressure ratio, which indicates the amount of thrust produced and represents the relationship between the turbine discharge pressure and the compressor inlet pressure. And differential pressure rate transducer between indicates the EPR values on the gauge. And the EPR automatically compensates the effects of airspeed and altitude. And for the ambient temperature, correction required for the accurate information need to be correction. And turbine discharge pressure, 57 gauge indicate turbine discharge pressure, and this pressure needed to be corrected for the variation in the pressure, temperature, compressor inlet pressure, and the altitude. For next, we learn the tachometer. Tachometer is for the turboprop, turboshaft is the torque produced to rotate propeller or the rotor. They are all calibrated in percentage or foot-pound or PSI or shaft horsepower. Type measure the 3 ways: measure the shaft twist caused by torque, or measure the pressure on oil-filled cylinder and piston sensor, is measure the torque pressure. The third way is the strain gauge. Use the principle of resistance, changing its resistance. And next we learn the fuel flow indicator, indicating pounds of fuel per hour, measure mass of flow, not volume, and fuel totalizer, various parameters for use and fuel remaining, fuel consumption rate, fuel remaining for flight, and if it's linked to the DME, distance measuring device or GPS. It can tell the range of aircraft and fuel efficiency. And then we learn the EGT, exhaust gas temperature. It's the most one of the critical elimination factor for operation and prevent overheating, torquing plates, exhaust components. Common way of EGT is TIT, most critical engine parameter, not practical for some large engine. TOT, temperature of turbine discharge EGT, relative to indication of TIT and ITT between two turbine stages, directly proportional to TIT2. And the chromium aluminum thermocouple, which is one is white and one is green. They can withstand high pressure and high temperature. Use a specific register. It's called ring register inside of the thermocouple. And also for the extra thermocouple leads, you shouldn't cut it because it's gonna influence the resistance of the register in the thermocouple. Engine indicating and the alerting system, which is ACAS. Two displays for power plant instrument on the middle of the instrument panel. Primary screen shows the EPR and 1 EGT with digital number and the analog changing. Secondary screens showed up N2 and 3, fuel flow, oil pressure, oil quantity, oil temperature, and the vibration. They may be blank in cruise. Crew alerting function, system faults and warning caution message. Can be changed to electrical, hydraulical, bleed air pressurization system. And then we learn the ground operation. And for troubleshooting, performance test before and after inspection, taxing, and specific information for engine and airframe, use the aircraft maintenance manual, checklist, and instruction. Just preparation for start. Landing gear pins in, heavy wind, choke the wheel, check the fault, pre-flight check, walk around, GPU, APU, that's the correct power, voltage, and fire extinguisher just in case those wheels steering locked, unlocked, it should be activated, fan free to rotate, not iced, and check valve, oil, and fluids. And pre-start, check all of the controllers down and after position, landing gear down and locked, master switch off, generator off, almost all of the switches should be off, and then turn on the ones we gonna use, like master on battery or external power on, and fuel booster power on, cut off, shut off, disengage, GPU, APU, bleed air, adjusted to 40 PSI, check hydraulic pressure, set brake, beacon off, communications with the ground and the flat deck, and test the fare system. Okay, here we start the engine. Start on, starting air pressure valve is on and into rise, and then oil pressure rise, and at 50% of natural ignition is on, and 20% of into power lever. The fuel switch is on, and you can tell the fuel flow from the indicator of fuel flow, and TIT rise, that means combustion happened and all lights off, and check the N1 rise, and 50% of N2 arrived, and it's at the speed of self-sustaining or acceleration speed, and after that the SAB start air valve is closed and the ignition of hot start. Fuel rich air mixture exceed operating temperature limit, immediately shut off the fuel, not the starter. And the hot start with normal temperature limit and fails to accelerate to reach idle, shut down engine. Caused by faster starter cuts off, not enough starting power source, idle speed stopping from 40 to 70%. Engine failure, cut off the fuel flow with continuing motoring with the starter. And if fire persists, isolate the engine. If fire still persists, spray small amount of CO2, not excessive, can damage turbine section by cooling effect. Power check, which equals to trim check, power assurance in engine performance, matching to trim speed data plate. Power check not same as trim check, using identified speed less than trim speed data plate. And compressor inlet air temperature and pressure measurement must be accurate for computing in takeoff thrust. Check compressor inlet air temperature using thermometer in the shade of compressor inlet, and field barometric pressure is unusable. Correct to the sea level and use the incorrect barometric pressure, which is the field pressure. And humidity knowledgeable on the thrust the turbine engine measures is unnecessary to checking engine performance. For engine shutdown, idle at least 30 seconds. 3 seconds to 5 minutes or more depends on the maintenance manual. Stabilize temperature, hot section, oil system scavenging, more power lever to cut off or fuel shut off valve, turn off after combustion ceases. Tread monitoring, spectral oil analysis program, which is soaked sample mechanic failure. Engine stays normal or goes down, WIF, fuel flow rise, TIT rise, that means the tip clearance of section turbine blade tip clearance, and NG rise, fuel flow rise, TIT rise, and it means the fault in compressor blade, cold section. And cold weather operation, ground power supply to start a cold socket engine to ensure adequate rotating speed, reheat, and no N1 build up to fan. And EGT indication might be lower than warmer weather. Starter oil viscosity higher, oil pressure higher for still until the oil wall in 1-3. Oil fuel bypass light may be on because of the high pressure and cold weather. In engine performance, engine power rating based on type certificate data sheet expressed in deeper than 1% or torque. Takeoff power rating, power permitted to produce takeoff time limited, over limit, torque could overheat, maximum continuous power lever used unusual, emergency synonymous with maximum cruise power, not subject to any time limitation, but result in more fuel, less AC range, less efficiency. Cruise power rating provided by the balanced fuel economy. Maximum climb power rating used for normal climb to cruise altitude higher than cruise power. And ground idle, lowest speed permitted on ground operation, and flight idle, lowest speed permitted in flight for descent, approach, landing, 10% higher than the ground idle. Stall protection is for the stall protection, and quicker response for power recover. Derated engine, power output intentionally limits to less than the maximum power that the engine can produce. Aircraft doesn't require or can't stand on the engine maximum rate power, increasing engine life but the less fuel efficiency. Hard throttle engine, flat rated, produce takeoff throttle under standard sea level conditions before full throttle position. Maximum power of takeoff power changed by atmosphere condition, can produce the same thrust in all conditions. Do not exceed the takeoff thrust setting when conducting a ground run. Most commercial turbine engines are part throttle. Full throttle engine immediately. Takeoff power, full throttle position at sea level day, and total thrust output With temperature up, its decreased. Temperature goes down, its increase. Automatically controls over speed and over temperature, and only full throttle for takeoff in any atmosphere condition. Next, maintenance. Maintenance continued airworthiness section instructions, maintenance and overhaul. Maintenance, other servicing, troubleshooting. Troubleshooting schedules for cleaning, inspection, adjusting, testing, lubricating. Maintenance airworthiness limitation, mandatory replacement times, inspection intervals, components, sections, limits, inspection intervals, calendar time or aircraft hours or cycles, shop maintenance, heavy maintenance. When overhaul facility with engine removed from aircraft. Limit line maintenance. Line maintenance, any maintenance that can be performed while engine is installed on an aircraft. Inspection, troubleshooting, cleaning, trimming, verifying instrument reading, fluid level check, replacement accessories, field cleaning. Cleaned periodically, followed by the maintenance manual. Aerodynamic efficiency of the compressor blade, decrease dirt, oil, and soot. A fluid wash, clean demilitarized water or emulsion cleaner sprayed in engine tank. Desalinization wash water alone to remove salt deposit. Performance recover wash emulsion cleaner followed by water, rinse and recover. Remove dirt, salt deposit, monitoring wash, turboprop, a fluid wash into the compressor inlet duct with the engine motored by starter, abrasive grade blast cleaning, injection abrasive grade cable blast into the engine inlet, selected power setting only washes compressor, cargo blast. Typically contains ground walnut shells and apricot pit. Use procedures and type of amount as per maintenance manual. Engine trimming, precise of adjusting FCU, produce maximum rated thrust, perform after engine or FCU troubleshooting, not producing maximum thrust. Vary between engine model, follow maintenance manual. And install calibrated instruments, turbine discharge pressure, and EPR, and N2 RPM tachometer. Point AC to the wind, excessive wind will result in low trim setting, elevated EPR and turbine discharge pressure. Measure barometric pressure and engine inlet ambient temperature, ideal conditions, no wind, standard temperature and pressure, calculated maximum power output of in accordance with maintenance manual. And next we learn the EGT tachometer checks, and we learn use the most important factors affect the turbine life. Serious damage can occur checked periodically. Excessive high EGT can reduce turbine blade life by as much as 50. And we can use the jet cal analyzer to check the indication of tachometer, also with the EGT temperature indication check and functional check. And then we learn the engine removal. The engine assembly can be removed as a one unit quick engine change assembly. And also we learned the shingling. It means the span jolt on the fan over blade rather than touch the face-to-face contact. It's happened because of the strike. And then we learned how to remove the engine and the engine lifespan. And also we learned the foreign object damage for the compressor, and hot section most damage probably because of the high temperature overheat, and preparation for the removal of engine and ignition, fuel system, battery disarming and disconnect all of them, and propeller removal. If it's a turboprop, we should remove the propeller before we remove the engine. And take off the electrical disconnection fluid line disconnection, engine control disconnection, and other stuff, accessories disconnection. And then we do the all engine hosting, engine compartment, check the engine compartment, and we after is removed, we check the engine mounts, and after that remove of the accessories, and the engine is gonna be overhaul the procedures and disassembly the engine each components and cleaning, check the bearings. There should be no tolerance for bearing damage, and do the visual inspection. And we can also need to do the NDT, which is specified by some other group, and compressor section, and combustion section, turbine section, turbine nozzle vanes, turbine disc, turbine plates. And then we learned the engine sulfidation. Stage 1, the sulfidation slightly roughness of the surface and breakdown of the coating acceptable in the field. And stage 2, medium sulfidation, heavy roughness of surface, vast material affected, still acceptable in the field. Stage 3, severe sulfidation, heavy roughness of the surface, build-up of blister-based material affected, late integrity effect. And the stage 4, deep penetration with metal separation, blade fracture, imminent, unbalanced rotor. And that's it. Thank you.